Hi everyone, this is EasyPeps and welcome to another Houdini tutorial. In this one I'll show you how to create this kind of effect. So we're going to take a custom curve and generate all this swirly behavior around it with some Vex Code, and we will also add a simple grow animation like this. So let's get started, and inside Houdini create a geometry node and dive inside. Now we're going to create our starting curve, so let's drop down a curve SOP. And since we are going to draw a curve, maybe for convenience we can switch to the forView, and you can do it either with this button or with the B shortcut, but keep in mind that it works only if you have the view tool active. So select the tool and then with B you can switch back and forth from single to forView. Now we are going to create a polygon curve, so change the type to polygon and let's draw our curves. Now by default, when you create the curve tool node, you are in draw mode, so as you click you generate points in the viewport. So create something, I don't know, like this. And when you're done, you right click and select finish edit points or just press enter. Now to edit the points, you press F. As you see, from F to G to H, you change the mode of the curve node. With F we are in edit and we can tweak our points now. And you can tweak the points or the edges, it's up to you. We are just going to tweak the curve to have something a little bit more interesting. Something like this maybe. Yeah, this should work. And after it, drop down a resample node and on treat polygon as, change the type to interpolating curve, and that will smooth our curve. Now to create the twist effect, we need a few things from our geometry. So let's switch back to single view. The first thing is this curve view attribute. So turn on the resample node, and this one will generate a float attribute going from 0 to 1 along the curve. You can actually visualize it if you hover the node and click on the eye icon. You see you have all the attributes listed here. You can click on curve view, and in the visualizer panel, which is this one, you have the curve view visualizer now. So turn on the visualizer and edit, because by default, I don't know why, it will be created as a color visualizer. It's not a color, it's a float. So change type to marker and the style will be switched to text. So if you zoom, or maybe I can decrease for a moment the resample length, you see that the curve view attribute is going from 0 to 1 along the curve. The next thing we need is the point normal, and I want the normal to be oriented along the curve. So let's turn off this curve view visualizer, and we're going to use a polyframe node. So let's drop down one and turn off the normal name and change the tangent name to N. So if you turn on the normal display, and let me create another node just to delete the primitives, you see that we have the point normal oriented along the curve, which is what we need. Now if you press D, you go in the display option. On the guides tab you can increase the scale normal parameter, so we have a better visualization of it. And let's drop down a point wrangle and start to create our effect. Let's rename it to something like twist. And let's see what we need. We need to, let's retrieve the curve view attribute, creating a float variable called view, and let's retrieve the curve view because we will need it. Now create a vector variable called up, and let's set it to 1, 0, 0, and I'll explain you why in a minute. Also create a vector attribute with our up variable so we can see it, and we are going to create the visualizer for it. So what we have now is two vector attributes for each point. And basically what we're going to do is an operation called the cross product. And when you do the cross product between two vectors, if you imagine a triangle formed by these two vectors for each point, the cross product will give us the perpendicular vector to each triangle. And we are going to use this vector and rotate it along the curve to generate the spiral. So let's do it right now. So going back to the point wrangle, let's create another vector and call it spine. And the function is called cross, open parenthesis, and it wants the two vectors. So one is the normal and the other one is the up. Let's also create an attribute to display it and create the visualizer for it, which is been set as a color. I don't know why. Let's revert it to marker and vector. Also set it to red. So as you can see, we have the correct vector, which is the red one, and it seems normalized, but just to make sure of it, put a normalize before the cross product. Normalize. Now, if you draw a curve like mine, you should be fine with the vector, should be all correct, but you need to keep in mind that your up vector, it needs to be set correctly. In this case, the curve is going up, so an up vector pointing on the x-axis is fine, but let's say I set up the up vector on the y-axis, you start to notice some flipping on the vector. And after some debugging, I noticed that this problem occurs when the normal, which is the blue vector, change sign. You can see here we have this problem around 0.38, and if we go in the geometry spreadsheet, you can see that just around this point the normal on the x-axis change of sign, and that caused the flipping. That being said, I noticed that even with this problem, after you apply the twist and the noises, the effect still looks cool. But for the sake of argument, let's say that we want to set the up vector properly. So keep that in mind, and if you have a curve, let's say on the z-axis, maybe you want to set the up vector on the y-axis. If you have a curve that is very long and is going in multiple directions, I'm sorry, but I still didn't figure it out how to fix this completely. But you should be fine too at the end of this video. Now that we have the vector, let's hide the up, and we can also delete the add node. We don't need it, it was just to show the normal better. So we have the vector, we need to rotate it. And to rotate this vector, we are going to multiply it for a rotational matrix. Now, I will not go deep into matrix. For the sake of this tutorial, you just need to know that you can apply transformation to your geometry with matrix. So, as we say, we will multiply the spine variable for the new matrix that we still don't have it. So, to create a matrix, we type matrix and 3 in this case because we want a 3x3 matrix called rot. And to initialize the matrix, we use something called the identity matrix. So ident, open and close parentheses, and this will create this kind of matrix, which doesn't affect our transformation yet, but we need it to initialize and use the rotate function. Now we have the matrix, and the spine variable is actually being multiplied by it, but it doesn't do nothing because we didn't declare any rotation yet. Now to rotate the matrix, we use the function rotate, and it comes in different possibilities. We will use the one that will ask for the matrix, the angle of rotation, and the axis. So we have our matrix and we need the angle and the axis. The axis is pretty easy. let's create a vector variable called axis, and it's our normal, so fn. As for the angle, we are going to create a float variable called angle, and we will use a float parameter to drive it. So chf and call it angle, and click on this button to create this pair parameter. Right now it's going from 0 to 1, this should be in degrees, so let's click on the gear, edit parameter interface, and set it from 0 to 360, because we want a full turn at least. For the function itself, it needs to be in radians, so we need to convert it, so radians, and convert this angle. Now we can use the rotate function to rotate the matrix, so rotate, and we will input the matrix, the angle, and the axis. So if you change the angle value, it's working. Right now it's rotating all the points on the same value, but it's working. So now to make the actual spiral effect, we just need to multiply this angle value for the curve view that we store into the u variable. And let's set it to 360, and you may notice that it does a full turn. Now we can multiply this also for another parameter we are going to create. Let's call it turn. So we can, let's say, add 10 turn to it and lower the resample, and we have 10 turn of a spiral over our curve. And finally, to actually apply the deformation, we just need to add this new vector to our position. So at p plus or equal spine. And there you have it. Now I know that for the entire effect I want many copies of this curve, so before the twist, let's create a copy and transform node, and for the time being just set it to 10. And I also know that I want to apply some noise to this curve, so let's create a point VOP and dive inside. Drop down an anti-aliased noise, plug the position, and we will add it to the current point position, and plug the output in the position. Change the noise type to 3D noise, and we need to fit the noise, because by default I believe the anti-aliased noise goes from minus 0.5 and 0.5. So let's set the minimum, the maximum, and remap it from -1 to 1. So we have a full noise around the curve. And we want to promote the frequency, not the offset, because we want to animate that, so leave it as it is for now. Let's promote the amplitude and the roughness. And we also want the possibility to control the noise over the curve, so let's drop down a bind node and import the curve view attribute. We can use it to remap a ramp parameter, so let's plug the curve view into a ramp, change the ramp type to spline, and now we can multiply the result of the noise over the ramp and add it to the current position. So if you go back now and we change the ramp, we should see the result. Yeah, so we can, add noise at the center of it, but not at the start and the end, and whatever you want. So we can do something like, if you change the point type to B-spline, we can do something more smooth. And also let's set the amplitude to, let's try 0.2, we want a very light noise, and also lower the roughness. I don't know why I'm seeing these copies. I believe my viewport is stuck. So it's a good chance to actually save this project. So give me 1 second. And if you have trouble like this, that you hide all geometry but you still see something, normally you would close this scene view and open a new one, but recently SideFX added this button on help. You click on reset viewport. Half of the time it crashes. This time it won't, and now we can see correctly. Basically, it does the same thing. It closes a scene view. You see that right now is here and not as the first window, because it closed the scene view and created a new one. So, but it's a convenient button to have it, because sometimes the viewport of Houdini gets buggy. Now, if we re-enable the copy node, we see that the noise is the same for every curve. So we want to change that. So going back inside the point VOP, you can use the primitive number, because a curve is made of only one primitive. So we have a different number for each curve. And we will use it to generate a random number. So plug the prim number into the pos. And we want this to be a 3D vector output, so we can plug it into the noise offset. So now the noise is different for every point, every curve, sorry. And we want also to animate the noise. So going back into the point VOP, unplug for a second the offset, because this is the parameter we are going to animate. So we can use this frame value to create an animation. So let's add to this random generated vector the frame value. And be careful, because what we are doing right now is to add a float value, because frame is a float value, to a vector one. So just make sure to plug the vector value as the first one, because otherwise it will output a float value and it will mess up the offset. So if you turn on the real-time toggle and press play, the animation is working. It's too fast right now, so we can add a multiply constant between the frame and the add. So we can use this value and set it to something like 0.1, and it should be slower. Yeah, maybe even slower, 0.02. Yeah, that's nice. So go out from the point VOP and let's see with the twist. So the effect itself is working. Now what we want to do is to offset the spiral effect itself based on the copy number. So all we need to do is to add some offset value to the angle itself. So let's create a float variable called offset. And for now, let's create a parameter, a float parameter. So chf offset. And we want to add it here on the angle variable. So plus offset. Now, if we change this new parameter, we see that the spiral is going upward or downward, depending on the value. And we want to use this value with and we want to drive this value with a random generated number like before. So instead of the float parameter, we will use a random function over the primitive number. So we are generating a random number for every curve again. And we also want to add, for safety reasons, some random number. And you see now is differentiated from 0 to 1, because the random function goes from 0 to 1 no matter what you input into the function itself. So we want to fit this new value, and we can use fit 0, 1 because we already know that the random output from 0 to 1. And the new remapping value will be this new channel we're going to create. So CHF, and we will call it min off for minimal offset, sorry, and another channel for the max offset. So if we create this page parameter, now we can increase this to a very high number, and we have a very nice offset on the various curves. We can also increase the number of copies and increase this even more. It's quite nice. And we are going to add more animation to it, but it still has the, the offset of the noise we already animated, so it's quite nice already. So the next thing we want to do is to define some scale value, because right now, since the spine is a normalized vector, over the operation it always output a uniform radius, So we can multiply the output value of the spine for a new scale value, and we get to control the whole radius of the twister. So let's create some new float variable, call it ramp scale, and we want to control it with a ramp, so chramp, and call it ramp scale. And to drive this ramp we will use the curve u, so u, and we need to multiply it for the spine here, so ramp scale. Click here to create the spare parameter, and if you look, we have a uniform scale going from 0 to 1 because the ramp is defining it. And this is giving us the control, but the control from 0 to 1, so we need to also remap this ramp. So we can use a fit 0, 1, because a ramp always output from 0 to 1 like the rand function, and we will fit this whole ramp to some new channel we're going to create, so say CHF min scale and CHF max scale. Click on the create spare parameter, and now if we say let's see 1 to 5, and maybe reset this horrible ramp, change the point type to B-spline, we have the complete control over it. And we can also redefine the min scale and max scale for it. Now the last thing we want to do on this point wrangle, let me reset the ramp, is that now it's randomized, but it's basically just an outline. We don't have any volume on this mesh. So what we're going to do is to create another float variable, call it scale offset, scale off, and we want to use a random function over the primitive number plus some random seed, and we want to multiply it after the ramp scale. So it was scale offs. So right now it's randomized from the max width from 0. So we can also remap this, so we have control over it, and we will use fit 0, 1, and we will remap it from a new channel called min scale off and CHF max scale off. I forgot the underscore, and we should be it. So create this pair parameter and set the max scale off and min scale off. So if everything is on 1, you have the same result as before, but as you lower the minimum, you're going to fill the mesh. If you increase the max scale off, you are going outside the max we define on the scale parameter. So you have full control over it. So to make a quick recap, I believe on the point wrangle we can go on the edit parameter interface and delete this offset that we created before for testing purposes. So what we have a curve that we can edit by moving the points, always keeping in mind the main direction for the up vector. We have the number of copy, so we can create it as many as we want. We have our noise parameter on this VOP. Let's rename it to noise. And we can control the twist over here. We can define how many turns. We can define the angle, although I believe you should leave this to a full turn. We have a minimum offset and a maximum offset. We have the scale value. And we have the possibility to fill the mesh, scattering the curves on a different scale value. And overall, we have the little animation from the noise. So right now we want to add the animation to the curve itself. To do it, we just want to create a new float value, call it frame, and we will use the frame variable, frame attribute, which is basically the current frame, and we will multiply it by a low value like 0.05. And basically we want to add this new frame variable to the minimum and maximum offset so they can move at the same speed. So plus frame, and after the first parenthesis, not the second one, plus frame. So now the curve should have a movement, yeah. And if you like it in the other direction, you can always do minus frame, and it should go in the opposite way. Yeah, it depends on what you want. So our setup is pretty much complete. All we need to do now is to create the animation for the growing effect. And for that we are going to use a curve swap. In my case, I want to use the second U parameter, because I want to animate it from the start to the end. And as it is, it will not work good because it's clipping all the curves at the same height. So we need to generate some number to create some offset between the curves. So let's drop down another point wrangle after the twist and call it anim. Now, since we have to offset the whole thing, I don't want to create some keyframe on here, because it would be messier. So I will create some parameter to drive the animation inside the point wrangle itself. So let's start by create a float variable and call it anim. And we will use the @frame attribute, which is the current frame number, divided $rfend, which is the total number of frame we have in the timeline. So 250 in this case. So this is basically giving us an animated parameter going from 0 to 1 during our entire timeline. And we can store it in a float attribute, call it curve, because we are going to use it to drive the curve. So we can see it in the geometry spreadsheet. I already filtered curve. If you type here the name of an attribute, it will show only that one. And if we scrub the timeline, you can see that it's going from 0 to 1. Oh, and also we need to run this on primitive, because we want for each curve, not for each point. Now, the problem with the curve is that even we created the attribute, apparently he can't read it. So if we type @curve, it doesn't work. It gives you a warning, local variable not found. So we need to use another expression called prim. So it's prim and it's asking for a few input. So it wants the geometry node, which is the first input, so 0. It wants the primitive number. So let's write prim num. It wants the attribute name, so curve as a string variable, and it wants the index output, which can be 0. Now we still don't see nothing, and we still see the error, local variable not found, because apparently it doesn't read the prim num attribute. So we need to do a little workaround to make it work, at least in this way. So before fixing that issue, let's apply this random offset we want. So we need a random number and an offset value. For the random number, just create a float variable. We will call it iter for iteration, and we will use a random function over the primitive number plus some random seed. And for the offset, we are going to create another float variable, and we will fit with 0, 1 the random number, which is currently going from 0 to 1. We want to fit it from like 0 to 0.2. We need a small value. And now we can subtract the offset from the anim. So what we did is we basically took the entire animation and randomly added a delay to it based on each curve. So each curve can have a minimum delay of 0 and a maximum delay of 0.2 in the animation. If we go in the geometry spreadsheet, on the last frame, you will see that not every curve has reached the full animation. So we basically added a random delay to each curve. Now we need to find a way to explain that to the curve node. So the problem with the curve node is that it can't read this attribute, but the expression itself, it works. If we put an explicit primitive number like the 0, so the first primitive, you will see that it works, but it reads the value from the 0 primitive and apply it to every curve, and this isn't good. So what can we do is to create a for each primitive loop. We can feed the anim point wrangle inside the loop and use the curve inside it. So now we have this nice offset on every curve. And as a last touch, we can also animate the turn amount. Let's also tweak the scale, like, you know, something more interesting. And we can animate the turns with simple keyframe, like we can start with 1 turn, and we can reach like 5 turns to the end of animation. So we basically create something like this. And that's it. You can increase, of course, the amount of copies. Keep in mind that it will lower your scene. And as far as my scene, I just added a p-scale and a color attribute to create some variation. And keep in mind that if you want to render it with redshift, you need to turn on the render object as strand. Otherwise, you need to add some thickness with some polywire or something else. So that's it for this video, and consider to subscribe the channel if you enjoyed the content, and I hope to see you in the next one.